Hello everybody, welcome back, and it's my absolute pleasure to introduce Andy Behr, who's the Technology Manager from Panasonic. Special thanks to Panasonic, who are one of our gold sponsors, so do please drop by and see their booth. And he's going to give us a talk now on the development of stretchable, conformable and pliable circuit materials. So over to you, Andy, and I'll be back at the end to take your questions.
Oh,
thank you.
Beautiful. Thank you, Chris. And thanks to TechBlick for putting this on, a wonderful list of August speakers. I've just seen some terrific presentations today and learning some really, really interesting things. So it's a wonderful platform and it's great to be here. So today I'm going to talk a little bit about Panasonic's development of stretchable and conformable and pliable circuit materials. And so up here on the screen is myself, Andy Behr, and my partner in crime, Takatoshi Abe-san, who is one of the developers of this material. I'm going to fill you in a little bit about that. So over there on the left, you see my picture. That's obviously pre-COVID. And then here I did a mock-up of my post-COVID picture. So you can see how things have progressed. All right. So being that I'm a little bit of a lighthearted individual, I always like to start by playing a game. And I didn't know, but in the US here, we have Sesame Street. We all grow up with Sesame Street. As I was researching this, I also found out that Sesame Street is also a phenomenon in parts of Europe as well as China. I did not know that. So one of the most famous sections of Sesame Street is a song, which is called "One of These Things Is Not Like the Other." It's a game. One of these things is not like the other ones. Anyway. If you're of a certain age, you'll know that song. And the way that game works is we put up 4 items and then you tell me which one is not like the others. Now we're not going to do a poll, we're just going to play a game. All right, so I put 4 items up on the screen. You can see we've got the world, we've got people, we've got transportation modes, and we've got electronics. So by the end of the song, can you tell me which one of these is different from the others? All right. Let's take a look. The Earth, not flat and rectangular. People, definitely not flat and rectangular. Cars, trains, and airplanes, mostly not flat and rectangular. And electronics, definitely flat and rectangular. And so you have to ask why. Why are all the electronics flat and rectangular? And I would posit that it's primarily that's how we can make them. And we're limited by our manufacturing and our materials capabilities. But we have emerging end uses and emerging devices now, which are driving change or demanding change, right? Flat and rectangular, planar and hard is not acceptable anymore. So we've got, you could say, extension of existing applications and markets like medical and aerospace and automotive, and maybe some adjacent markets like wearables and robotics that are demanding new form factors and new functionality and new reliability, right? I mean, we never really had to worry about high scale, high volume, dynamic mechanical flexing, washability, conformability to the skin. So these new uses, these new applications are definitely driving a whole new suite of use requirements and design requirements, and even some new devices like haptics and very specialized biomedical sensors. So what's the challenge then? What's the challenge? Well, you know, in the US, we sometimes occasionally like to make fun of our friends in Florida, and not without some merit here. If you see this sign, you can understand that basically you can't get there from here. So conventional manufacturing processes, materials, designs are not going to get us to where we need to go. There's going to be new approaches are going to be required. And those are processes, it's equipment, it's designs, it's integration. Being in Panasonic materials, we're focused on the new materials required to get us where we need to be. So let's talk just briefly. What are printed electronics? Well, printed electronics is basically the application through additive processes, whether it's contact printing or non-contact printing, and building up a device or a component using printing methods.